How you guys doing? All right, well today what we're going to do is we're going to take it back. We're going to go back to the beginning part of the school year. And what we're going to do is we're going to review to make sure we're ready for that test next week. All right? Make sure we understand some of the skills that we may have forgotten. First of all, so we're going to do two different things today. The first thing we're going to do is we're going to talk about the difference between rational and irrational numbers. And we're going to be able to tell by looking at a number whether it's rational or irrational. And the next thing we're going to do is we're going to take a look at some numbers that are related by using a chart. And we're going to take a look at this relationship and we're going to learn how to find the rate of change or slope from the data that's there. All right. Well, first of all, let's talk about rational and irrational. Okay. Now, I want you all to write this down. Put some notes up here. I want you guys to write it down with me. All right. So, first of all, we're going to talk about rational numbers versus irrational numbers. Okay, because there is a big difference between these. Okay. Rational versus irrational numbers. Okay. Now, the best way to do this is going to be to take a look and understand what an irrational number is. All right. Now, if you look at the first problem on your paper there, you got 61. I can't write, obviously. 61 pi. Okay. 61 pi. Is that rational or is that irrational? And the way we tell is by taking a look and understanding what an irrational number is. Okay. Now, an irrational number, there's only really a few types of irrational numbers. And what an irrational number is a number where the decimal goes on and on and on. It never ends. It never repeats. Okay. And it just keeps going on forever. Okay. Now, there's only three types of irrational numbers that we have to deal with. All right. Let me show you the first type right here. First type is going to look like this. The first type is this. Let's say something like 42.35723 ... Now, what does that mean? That means that these numbers right here, 42.35723, and see this ... that ... means it's going to keep going. It's going to keep moving. It's never going to repeat. These decimals are going to go on forever. Okay? And what that's called is called a non-terminating decimal. All right? So any decimal that is non-terminating, and the way you're going to tell is going to have the ... Okay? Now, the other type of irrational number we need to deal with is something like this. Look now. Pi. Pi is an irrational number. And the reason why pi is an irrational number is because it is the ratio of the circumference to the diameter, and when you divide those, the decimal just keeps moving. It never ends. It's non-terminating, okay? And it's never going to repeat. So anytime you see pi, you have an irrational number, all right? Now, one more. The third one. The third type, and this is going to be the most common, all right? The third type is going to be a square root that is not a perfect square, all right? So look, the third type is a square root that is not a perfect square. Now, you may think, what in the world is a perfect square? Perfect square. There we go. So what's a perfect square? All right. I like to make a little chart. Okay. Now, let me show you my chart. Here it is. Watch now. Okay. Here's my list of perfect squares. I got the square root of 0. The square root of 1. This is my chart. Write it down. Square root of 4. Square root of 9. Square root of 16. Square root of 25. Square root of 36. Square root of 49. Square root of 64. Square root of 81. Square root of 100. Square root of 121. Square root of 144. And so on. The square roots keep going. But why are these perfect squares? The reason why they're perfect squares is because we can square root all of them. See, the square root of 0 is 0 because 0 times 0 is 0. The square root of 1 is 1 because 1 times 1 is 1. The square root of 4 is 2 because 2 times 2 is 4. And so on. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. You got 8, 9, 10, 11, and 12. And so you could keep going on now. But let's just, for time's sake, leave it like this. So, if we take a look at our numbers, and once again, these right here, these three are all going to be irrational. Okay? All the other numbers we're going to see are going to be rational. So anytime you have a whole number or just a decimal that terminates, that ends, or if you got a repeating decimal, or if you got a square root that is a perfect square, then all those are going to be considered to be rational. All right? So what we're going to do is we're going to take a look at a bunch of problems and see if they're rational or irrational. All right? So take a look at this one here, 61 pi. Is 61 pi going to be rational or irrational? Well, if we look at what an irrational number is, it's a decimal that just keeps going, doesn't terminate. Pi, you see how you have pi in the problem right there? That means that this number right here is going to be irrational, okay? Because it has pi in it, okay? Now, what if we had another problem, something like this? Look now, 6 over 31. Now, how do we know if this is rational or irrational? What I do is I ask myself a couple questions. First of all, is it a decimal? No. So we don't have to worry about this. Next, we ask ourselves, is pi included somewhere in this fraction? Nope. So we know so far it's rational. And the last thing I do is look, number 3 has to deal with square roots. Is there a square root in 6 over 31? No. Therefore, this number right here is rational. Okay? That's all we got to do. Now let's take a look at another one now. Take a look at this one. Look at this. Square roots of 101. All right? Now look, is it rational or irrational? First, is there a decimal? Nope. Is there pi? Nope. Is there a square root? Yes. So what we do is we ask ourselves, is 101 on our chart? So we look, let's look for where 100 is. Oh, here it is. Now look, it goes 100 to 121. Do you see how 101 is not in my chart? Therefore, because it's not in the chart, we know for a fact that this is going to be irrational. Because 101 is not a perfect square. There is not two numbers that multiply together to give you 101. Therefore, it's irrational. All right? Let's try another one. What about this? Boy, here comes a toughie. Watch. Look at this. 57.013. Like that. Now, what is this? Well, let's take a look. Is it a decimal? Yup, it is. Is this decimal going to keep going on and on and on but never repeat? No, it will repeat. And the reason why we know it repeats is because it has this bar above the 1 and the 3. What that tells me is that this 1, 3 is going to keep repeating. It's going to be 57.0131313131313. It's going to keep repeating. And when it repeats, it is a rational number. So this right here is going to be a rational number. All right? Now, that's all you got to do to tell. Remember, 3 questions. Is it a decimal? If so, if it keeps going with the dot, 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 it's going to be irrational. If there's pi in it, it's going to be irrational. If it's a square root that is not a perfect square, a square root that is not on this chart, now keep in mind, you can go up, like the square root of 169 is 13. It's going to keep going. So if you got a bigger number, you really got to take a look. But most of the problems we have are going to be on this chart here. Okay? Next, and if you have one of those, it's going to be irrational. Now, one thing I want you to do is I want you to really make sure you pay attention to this next problem. All right? This next problem is a little bit tricky. Sometimes you may see one like this on your test, but take a look at this. What if you have one that looks like this? The square root of 50 over 8. Okay? Now, if you look at that, you may say, that's irrational. There's no 50 over 8 on the chart. And that's right. But it's a fraction. And when it's a fraction, what you need to make sure you do is check to see if you can reduce. So can we reduce 50 over 8? We can. 50 and 8 both can be divided by 2. So what I'm going to do is I'm going to reduce this fraction first by 2. So I'm going to divide this by 2 and divide this by 2. And look what happens now, folks. Look what happens. The square root of 50 divided by 2 is 25. 8 divided by 2 is 4. You see that? Now if we look at that, look, is 25 in your chart? You bet it is right there, because 5 times 5 is 25. So what this is going to equal, look now, the square root of 25 is 5. And the square root of 4 is 2. So see, what we really have, this really is 5 over 2. Now look at your answer. Is there a decimal that keeps going? No. Is pi somewhere in there? No. And finally, do you have a square root that cannot be square rooted? Answer is no. We got 5 over 2. There's no more square roots because we simplified the problem. Okay? So if you do those things, you're going to be able to tell very quickly whether you have a rational or an irrational number. Okay? Notice, I didn't put anything for rational because rational is everything else. Alright? So just remember, ask yourself a few things. First off, is there a decimal that keeps going and does not repeat? Next, is pi in your work somewhere? And finally, do you have a square root that is not on the chart? Okay, if you have something like that, you have irrational numbers. All right, now that's the first thing we're going to do. Hopefully that made some sense. All right, now what we're going to do next is now we're going to take a look at some numbers. We're going to look at a relationship, okay, of numbers. And let me show you what this relationship is. Watch now. What we're going to do is we're going to find this rate of change Okay, so we're going to find the rate of change. Now, I want everyone to understand something about rate of change. Rate of change is the same thing as your slope. So if you find the slope, you are also finding the rate of change. Sometimes they're going to ask that. What's the rate of change? What's the slope? You need to understand that the rate of change and the slope are the same thing. Okay? So if it says rate of change, beautiful. If it says slope, no, it's the same thing. Now let's take a look at a chart here. Look at this. Now what if we had a problem look like this? Look at this. Here's a nice little chart here I'm going to draw. Okay? It should be on your worksheet already there, so you don't have to write it. But it's going to be, what is it, number of balloons, and then it's going to be something like total cost, I think. Okay? Now, next, I'm going to give you some numbers here. Let's say the first one's going to be 2, 6. Next is going to be 4, 12. Next is going to be 6, 18. And then finally, you're going to have something like 8 and 24. Okay? So if we look at this, all we have to do is this. We're going to take a look and see what the rate of change is. Now, what that means is this. If you went out to the balloon store and you bought 2 balloons, it's going to cost you $6. If you went to the balloon store and bought 6 balloons, it's going to cost you $18. And let's say you went and bought 8, it's going to cost you $24. If you notice, each balloon is going to be going up, and it's going up in a constant rate of change. Okay, meaning that each balloon costs the same amount. It's never going to be something different. Okay, they're not offering a special, buy 100 balloons, get some free. Not offering that. It's always going to be the same. It's constant. Okay, now, so how do we solve this? Now, some of y'all may already know how to do this. This is simple. That's right, but let me show you the proper way, the easy way to do it. Okay, the rate of change, or the slope, is found when you find the change in y over the change in x. So watch this. So for rate of change, this is going to equal, okay, the change in y over the change in x. So how do we find the change? Well, what we do is we pick 2 different sets of points. Does not matter which 2. You can pick the first 2, you can pick the middle ones, you can pick the first and the last. It does not matter. If it's constant, the rate of change will be the same. So what I'm going to do is this. To make it simple, let's just pick the first 2. Okay? So what I do is this. I ask myself, I like to make this little caret here so I know exactly what 2 points I'm dealing with. Now think about it. What are you doing to 2, adding or subtracting, to get to 4? Well, you're adding 2. What are you doing to the 6 to get 12? You're adding 6. Okay? So that's the first part of our rate of change. The next thing is you got change in y and x. What in the world? Which one is x, which is y? Understand that when you're dealing with the chart, go in alphabetical order like you're reading a book. The first set is going to be x. The second set is going to be y. All right? Now, what you do now is this. So you look, you got a fraction, you got a ratio, change of y over change of x. So this is all you do. What is your change in y? Well, here's your y, and your change was a positive 6. So you put a 6 here. What's your change in x? Your change in x is positive 2. So you're going to put a 2 here. Now all you do is simplify. What's 6 divided by 2? 3. So your rate of change for this problem is going to be 3. That is your rate of change or your slope. It's 3 for this specific problem. Okay? Now, that's all you got to do. Now, what if somebody got crazy? What if somebody said, well, hey, look, why don't we do this? Why don't we do the 2 and the 8? That'll be fun. And maybe we'll do the 6 and the 12. 24, you see how you have to use the first and the last and the first and the last. Let's see if we still get the same rate of change. Watch. What are you doing to 2 to get 8? You're adding 6, right? 2 plus 6 is 8. What are you doing to get from 6 to get 24? You're adding 18. Right? 6 plus 18 is 24. Now, let's see what our rate of change is. What's our change in y? It's 18 over, what's our change in x? It's 6. People, what's 18 divided by 6? It's 3. Now, if you look, these two numbers are going to be exactly the same. Why is that? Because the rate of change is constant. Okay? What this means is each balloon costs $3. Okay? So no matter how many balloons you buy, you're going to multiply by 3 to get the cost of balloons. Okay? Now that's one example. Now I'm going to do one more right quick because the next one we got some decimals in it, and folks get scared of decimals and fractions for some reason. Like they're a monster or something. They're not. All right? So let's do one more of these real quick with some decimals. I don't want to be afraid of the decimals. Here we go. All right. So here we're talking about number of lawns and the total earned. Okay? So we're talking about number of lawns, and then we're talking about total earned. Now sometimes you may see your chart written like this. Not all fancy. It doesn't matter. Okay? So here, if you mow 3 lawns, you're going to earn $25.50. Okay? If you mow 5 lawns, you're going to earn $42.50. Right? If you mow 7 lawns, you're going to earn $59.50. And finally, if you mow 9 lawns, you're going to earn $76.50. So this is your chart. So we're going to find the rate of change. How much are we going to earn if we mow 1 lawn? Well, how do we figure it out? Once again, we're going to pick 2 points. Doesn't matter which 2. All right? So let's just pick the first 2 because the first 2 are usually easiest, okay? So we pick these 2 and we pick these 2. See how they got to be the same. The first 2, the first 2. What are you doing to 3 to get 5? You're adding 2. What are you doing to 25.50 to get 42.50? Now, I don't know, okay? So what I do is I'm actually going to do the work over here. What I'm going to do to get the difference here, the change, is I'm going to go ahead and subtract 42.50 minus 25.50. And when I subtract, look what happens. That's 0, 0, 2, oh, got to borrow. 12 minus 5 is 7. 3 minus 2 is 1. So I got $17. Okay? Now, when you get $17, make it easy on yourself. You really don't need the 0.00. You don't need to change if there's no change there. So that's going to be, you're adding 17. Okay? So now, the change in X is $2 because you're adding $2. I mean, not $2, but you're adding 2 lawns. And then over here, when you mow 2 lawns, you're going to get $17. So to find the rate of change, to find the slope, what you do is this. The change in Y over the change in X. Don't forget, this is X, this is Y. All right? So the Y is 17 and the X is 2. So we got 17 divided by 2. All right? So what we do there is now we're going to have to divide. Now 17 divided by 2 does not go evenly. So what I'm going to do is I'm actually going to divide. Remember, the 17 falls this way. Right? Now 2 goes into 17 8 times. 8 times 2 is 16. Subtract, you got a 1. Now what you're going to do next, you cannot have a remainder. So you're going to add a decimal and a 0 and keep going. Decimal, 0, bring the 0 down. Bring that decimal straight up so you don't forget about it. All right? If you forget about it, it's wrong. Now 2 goes into 10. Look at that. 5 times. 5 times 2 is 10. Subtract, there is no remainder. Okay? So what's your rate of change? Your rate of change, people, is 8.5. Now, how would you make 8.5 into money? You would make it $8, and you can add another 0 here. You see that? Zeros you can add for free after a decimal. That's $8.50. So your rate of change for this problem is going to be $8.50. And what does that mean? That means that for each lawn you mow, you're making $8.50. All right? Now that is how you find the rate of change from a chart. Okay? Just to recap, you need to find the change of X just by seeing what are you doing to the first number to get the second number by adding or subtracting. And then the change in Y, once again, finding the difference between these two numbers. Okay, that's going to be your change. And then what you do is change of Y over the change in X. Y is always on top, X is always on bottom. Don't flip them, try to be cute, because you're not. Y on top, X on bottom. And when you do this, see, Y on top, X on bottom, then divide it. Once you divide, that's going to be your rate of change, which is also your slope. Now, I hope this made some sense to you. Okay? Now, careful. You got some negatives in there. Don't be afraid. Okay? No fractions. But just make sure you guys really find that change in Y and put it over the change in X, then divide. And you'll have that answer. All right? Well, thank you so much. Hope y'all enjoy and have a great day.